right, this is chapter 1, homework number 2, solutions video. I'm going to start with review question number 6. Okay, so we're on page 34 on the book, and I'm not going to put the book on the screen, just going to read them to you. So number 6, if you'll just follow along. Number 6 says, what do physicists mean when they say velocity is relative? Well, it depends on who is doing the observing. So, velocity So again, if you're traveling right next to someone on the highway and they're going the same speed as you, it'll look like they're going 0 miles an hour. But if they're coming the other direction at you, it'll look like they're coming a lot faster than what their speedometer would say. All right, number 7 says you're reading through someone else's laboratory notebook. You notice a number written down, 12.3 meters per second squared. Even though it's not labeled, you should immediately be able to tell what physical quantity the experimenter measured. What is it? Okay, if the unit is some distance per time squared, that's acceleration. Okay, number 8 says another experiment in the same laboratory notebook says that an object has a 1.4 meters per second squared acceleration, negative 12.6 meters per second velocity. At that instant in time, is the object speeding up or slowing down? It is slowing down. Why do I say that? It's because, and we do this in calculus as well, velocity and acceleration have different signs. Okay, number 9, what kind of graphs do you study if you're interested in learning about acceleration? That'd be velocity versus time graphs. And then number 10, an object's velocity is 0. Does this mean its acceleration is 0? No. And that's because the object could be changing directions. So its velocity would be 0 at that point where it changes direction, but not necessarily the acceleration. All right, so there you have it for the review questions in Chapter 1. Of course, on tests, I always do the multiple choice and true-false questions. I draw on the review questions first and then the notes. So it's always good to study the review questions. Okay, and then the practice problems, number 5. So in this case, I'm going to go ahead and put the book into view. Hope you can see it. It says we have this position versus time graph. At approximately what time does the car change its direction? Well, it's going to change direction where the slope changes signs because the velocity went from positive to negative here. So that's at just a little after 6 seconds. So let's say about 6.3 seconds. If you had a little different from that, that's fine, because the slope changes sign at that point. All right, number 6, over what time interval is the car moving the fastest? All right, we want to find where is the slope steepest. I believe it's between 5 and 6 seconds. All right, that's the steepest slope on this graph. And it doesn't matter if it's positive or negative. If the steepest slope is negative, then that would be the fastest. So between 5 and 6 seconds, because the slope is steepest. Okay, number 7 says a train is traveling with an initial velocity of 20.1 meters per second. So let's just write this down. Initial velocity, 20.1 meters per second. The brakes can apply a maximum acceleration of negative 0.05 meters per second squared. How long will it take the train to stop? So we know the final velocity is stop. So that would be 0 meters per second. And what we're trying to figure out is the time, how long. I find this to be a very nice way to set up your problem. All right, write out all your variables and what do you know from the problem. Okay, so we know that acceleration is equal to change in velocity over change in time. And that's going to be the final velocity minus the initial velocity over the change in time. Okay, so acceleration is negative 0.05 meters per second squared is equal to 0 final velocity minus 20.1 over the change in time. So change in time, if we flip the one out front and the one underneath, is going to be negative 20.1 meters per second over negative 0.05 meters per second squared. And the units, the meters will cancel, one of the seconds cancel, and you'll end up with seconds. All right, and that's going to be, I believe, a little over 100. Let's see. No, more than that. So 402 seconds. So definitely over 100, way over 100. My mental math skills have declined some this summer. Hopefully they'll improve. Okay, and I want to make sure time can't be negative. If you ever come with a negative time, you've done something wrong. Okay, so negative over negative cancels out. We have a positive time there. All right, I'll go ahead and erase this. And let's get the last three. I believe they're all involved with a graph here. So number 8. We've got this velocity versus time graph. 8 says, over what time intervals is the runner slowing down? All right, the runner is going to be slowing down. I'm going to go ahead and write this out. Slowing down when velocity and acceleration have different signs. Okay, where does that occur on this graph? Well, between 0 and 6 seconds, velocity is in the positive territory, but the slope is negative. So that's the first one, 0 to 6 seconds. All right, it's speeding up between 6 and almost 12. Then between 12 and 16, acceleration is negative, velocity is positive. So 12 and 16, it's really more like 11.8, so I'll put that. And then when you get at 16 seconds, both velocity and acceleration are negative there. So it's speeding up. It's just speeding up in the negative direction, so to the left or down. So the answer, slowing down between 0 and 6 and about 12 and 16 seconds. So number 9 says, what is the runner's acceleration at 6 seconds? Well, you can see at 6 seconds, the slope is 0. It's changing direction there. Okay, so, and the slope, but the slope is 0. So you can have an acceleration of 0 when you have a change in direction. So for that one moment in time, the acceleration equals 0 since the slope is equal to 0. All right, and then number 10, what is the acceleration at 1 second? Well, what we have to do is pick an interval where the line is straight. I would say that's between 0 and 2 seconds, and where you can read it on the graph easy. Okay, so between 0 and 2 seconds, you can read it on the graph. At 2 seconds, velocity is 4, and at 0 seconds, velocity is 5. So the slope is equal to change in y over change in x. Right, so y sub 2 would be 4. Y sub 1 is 5. So we know acceleration is going to be negative because the slope is negative. And then we'd have 2 seconds minus 0 seconds. Now you could pick a different time interval, but it'd be a lot harder to read the graph. You could pick between 0 and 1, but the graph is hard to read there. So that's going to be negative 1 over 2. So negative 1/2 meters per second squared. All right, that does it for this solutions video. Make sure you contact me if you have further questions. Usually after this, we do the lab, and then the extra practice problems, and then the test. So that's where we're headed next. All right, so hopefully you will have a great rest of your day.